This is AP Calculus Self-Check 6.2 Solutions. This is pulled from the 2010 Calculus AB Free Response questions from the second form, Form B. Alright, so we have this differential equation. We are making ourselves a slope field. So again, this is saying the slope is all of this. So just start plugging in points. I'm just going to start, we'll start on the right. I like the right top point to start with. It doesn't really matter, it's personal preference. So this is x equals 1. All of these will be x equals 1. And y will be equal to, for this one, y is 2. So it's going to be 1 plus 1 over 2. 2 over 2, that is a slope of 1. This one is going to be y is equal to 1 now, so it's going to be 2 over 1, so it's slightly steeper, it has a slope of 2. And at y equals 0, it's undefined. I mean, we don't have any points that we need to find here. Next we have down here, so y has changed, y is now negative, so it's really saying that because this is the only thing that's changing, all of these slopes are just going to be the inverse of these slopes up here. So this is going to be a negative 2, okay, I can try to draw a straighter line, negative 2, and then a negative 1. Moving on to our next set of points. So over here we have x is always equal to 0 for all of these points, which means it's always going to be 1 over something. So it's going to be 1 over 2. 1 over 2 is a half. So draw a slope of a half. I can make it maybe a little bit less steep. It's going to be 1 over 1. So that's going to be a slope of 1. And this one is going to be just, again, the opposite of these. So it's going to be a slope of negative 1. It's going to be a slope of negative 1/2. Try again. Slope of negative. Can't draw a straight line. Good enough. Alright, moving on over here, we have all of these x's are negative ones, so this numerator will always be 0. So if it's always 0, then this is always going to be 0 over here. Perfect, so we just did that. We did the slope field, and now we're doing the second part. And for this part, between negative 1 and 1, so still on this x-axis, we need to sketch the solution of a curve that passes through the point 0, 1. Alright, so 0, 1, so I go 0 and I come, 0, negative 1, sorry, 0, negative 1. So we're starting with this point here. So I can kind of tell what happens on the right hand side. You can see that this would just be a straight line down here, so I could actually use my line tool to make sure that it's nice and straight. This would just be a straight line coming down through here off into what seems to be negative infinity in the y direction and positive infinity for the x direction. But does it stay the same over here? And like logic dictates, if this is a straight line, it probably will be a straight line. But how do you ensure that? And just with a quick calculation, if we'll test like a half. If negative a half is also one of the points that we can use, it has a slope of negative 1, then we know that it should be a straight line all the way until this point, negative 1. So what happens when we plug in negative a half? I'll get 1/2 over a half. A half over negative a half, and that will be negative 1. So again, the slope at this point that I just decided to make was also negative 1. We can see that this line just continues all the way until suddenly it's undefined. I can't divide by 0. Something happens here, but we don't care what happens after this because our boundary is negative 1. So that's the full solution for number 5. And how do we score? The first part for A, this is actually worth 3 points for the slope field. So you get 1 point for the 0 slopes. So if I come back here, every single one of these 4 points was correct, so I got +1 there. And I get another point for the non-zero slopes, so that's all of the slopes on the right-hand side. So those are 8 points. For those 8 points, we got those right, so I get another +1 there. And then it's saying I need to have the solution curve going through 0, 1, so I need to have that line. If I have that line correct, then I get another +1. Oops. So that's another +1. And already out of 9 points, I'm at 3 out of 9. I am on track for getting a 3 just from doing part A. And on to part B. So I have this description. So yes, it is drawn only at 12 points, but let's describe all the points where y doesn't equal 0, so I don't have any problem points, where the slope is negative 1. Where the slope is negative 1. So notice that I was talking about this line here. What is the relationship of all the x and y's? And I mean, this is just a linear line. If you were able to go back and say, oh, I know the equation of that line, you're basically done. But how do we do that using the equation? So we know dy dx equals 1. So coming back to our original equation, we can say, well, let's sub in this negative 1 for dy dx. So negative 1 is equal to x plus 1 divided by y. and let's make that into an easier equation to solve by cross multiplying. So I'm going to have a negative y is equal to x plus 1. And finally, you can just say y equals, you can say y equals negative x minus 1. That is the equation. I guess both of these are correct. But this is the equation that describes this relationship. Every single point that satisfies this, this slope is generated by this equation. So how do we say that in math? We say it has a slope of negative 1, so dy dx equals negative 1 for all values of x and y satisfied by that equation. For all, you can say x comma y pairs where we have this equation, where y equals negative x minus 1. As long as you have this guy, I think you get the points, but I'm not 100% on that because this is my first year teaching AP Calculus. And then you could also, if you're being really professional, I don't think you'd lose points here. You can also say, and make sure that you still have this condition, and y can never equal 0. That is the professional answer here. So this, oh, whoa, that was a weird box. This, I have this slope for all x, y, where this equation is held true, making sure that y is still not equal to 0. But generally speaking, that's the main part. Let's see how we would score this guy. So how do they say this? Yeah, they just subbed in same as we did, and they say almost exactly what we said. So as long as you have, I'm going to say, for my scoring, if you have this equation or this equation, some equation like that, give yourself a +1 here. +1 for having this equation. And finally to part C. So we're finding the particular solution. That means we're doing our 3 steps out of the 4. For y equals f of x, for this thing with the differential equation, and we say we're plugging in that number. All right, so fraction is equal to a fraction. We're good. Cross multiply, and we get y dy is equal to x plus 1 dx. Oh, how nice. We don't even have to rearrange anything. It's already separated. So our variables are separated. Now we're going to go ahead and integrate. So when I integrate, integral of y dy is equal to the integral of x plus 1 dx. And this is going to be, you go up a power, so y squared, divide down, so 1/2 is equal to, this is x plus 1. All of this, these are individual terms to the power of 1. So you're integrating x, and then you're going to integrate the 1. So integral of x is going to be x squared, divide down, plus, and then I'm going to integrate the 1. When I integrate 1, I just get x. And then don't forget your constant of integration. All right. And finally, we just want to do step 3, which is plug in our x and y values. So again, this was our x, this was our y. So we say 1/2, our y was -2 quantity squared, is equal to 1/2, and then plug in our x's. 0 squared plus 0 plus c. I guess I can put parentheses here to be formal about it. And it might be tempting just to put c here, but please just plug in 0 because it shows the work that you're using the initial condition, and there's less likely of a chance that you'll mess up. All right, we're done with step 3. We could move on to step 4 if you've watched that video, but let's just assume that we're going to stop here to see how many points we'll get. So our scoring guide. So we get 1 point for separating the variables. So we separated the variables all the way right here, so I'm going to change it red. We get a +1 for separating the variables there. We get 1 point for the antiderivatives this time. So 1 point if I can get to this step here. So all of this step without the c is +1. And then next it says constant of integration. So there's our c, so +1. And then finally, we need to use the initial condition. We need to plug in our x and y, and we did that in this step, +1. And we only missed 1 point for not doing all this extra work to get down to our final solution, which is fine. Make sure that you give yourself 0 if you weren't able to separate your variables, and I hope you did include your constant of integration. All right, so again, you're shooting for a 3 points. 3 points out of this entire problem. Between A, B, and C, did you get 3 points? So I know in the answer key, I only missed 1 point for not doing that integration. So currently, the answer key has an 8 out of 9, which is 0.88 repeating. So that's 89% roughly. And remember what you're shooting for. Just 3 out of 9 because about a 40% is going to be equal to the passing score of a 3. You want a 55% to get the 4, and you want the 70% to get the 5. We are definitely on our way to getting the 5 if you got all the slope field and stuff correct. Although I think probably the hardest question was this one, getting the solution curve. And even if you missed that, you should still get, where am I? You should still get a 77%, which is well above a 70%. All right, so that is Self-Check 6.2. Tomorrow we're going to be going through Self-Check 6.3 and 6.4. Remember to keep studying. Thanks.